Hello, welcome you all. Today's topic is computation of inverse of a matrix with the help of elementary transformation, and this method is also known as Gauss-Jordan method. Basically, Gauss-Jordan method is a method to find the inverse of a given matrix if it is invertible by utilizing a set of elementary transformation. Suppose we have given a non-singular matrix. Non-singular matrix is basically that matrix whose determinant is non-zero. That is, that matrix is said to be an invertible matrix. If given matrix is invertible, then the Gauss-Jordan method, the first step is write the given matrix A equivalent to the identity matrix of the same order as the order of A's. That is, we have, suppose A matrix is of order 3, then we write this given matrix A equivalent to the identity matrix of order 3. Then with the help of a sequence of elementary transformation apply on this form, this representation. Our objective is to reduce this given matrix A into identity matrix I, and this second matrix, that is identity matrix, is transformed into another matrix B. That another matrix B will be the inverse of given matrix A. This is our Gauss-Jordan method, which is basically an elegant way or convenient way to find the inverse of given matrix without calculating its determinant. So suppose we have to find the inverse of this matrix with the help of elementary transformation or with the help of Gauss-Jordan method. So our objective is first to write the given matrix A equivalent to the identity matrix of the same order as the order of A. So here A is given as the matrix of order 4. Therefore, we have written this matrix A equivalent to the identity matrix of order 4. Now, our objective is to reduce this matrix A into identity matrix with the help of sequence of elementary row transformations only. So, our objective is to convert this matrix A into identity matrix, that is, we have required all the diagonal entries must be 1 and all 9 non-diagonal entries are 0. So this is our objective, and these objectives can be achieved with the help of elementary transformation only, basically elementary row transformation only. So first we have required this entry. Our objective is first to find this entry as 1 with the help of some suitable elementary transformation. So this can be achieved by simply interchanging R1 and R2, or even we can interchange R1 and R3 in order to convert this entry into 1, or actually we need this place as 1. So therefore we have used this operation R1 and R2, that is, we have interchanged the first and second row. So this entry now is 1. Now our objective is to reduce this matrix A into identity matrix. So our objective is first all the elements below this first entry should be 0. So these entries are to be converted into 0 with the help of elementary operation. This is already 0. Now this entry 1, our objective is to reduce this entry 1 into 0 with the help of suitable elementary row transformation, and this can be done with the help of this entry. So the corresponding operation is R3 minus R1, and this entry minus 1. Our objective is again to convert this entry into 1 with the help of this 1. So the corresponding operation is R4 plus R1. So using these two operations, The same operations are also used in the identity matrix. So we have obtained this form with the help of these two elementary transformations. Now, our next objective is to find the second diagonal entry as 1. And there may be many combination of elementary transformation to convert this into 1. The first combination may be that you simply divide all the elements of the second row by 2. Then this entry also reduces into 1. But in the case that these entries will have fractional number, so in order to find next operations or in order to simplify remaining elements, we have to perform the addition and subtraction of fractional numbers, which is in general to be avoided as much as possible. So we have not used this operation here. Now our objective is to find this place as entry 1. So this can be achieved by simply interchanging the second row and third row. If we perform this elementary operation, then this place is now become 1, and with the help of this 1, our objective is now to reduce these two entries into 0, and the corresponding operations can be R3 is replaced by R3 minus 2 R3 minus 2R1 2R2, and this operation, this entry is reduces into 0 with the help of this one by taking the elementary operation. R4 is replaced by R4 minus 2 R2. Then the corresponding matrices, the corresponding form is obtained as this one. Now our next objective is to find this place as 1. So this can be achieved by simply multiplying the whole equation by minus 1, or first we these two rows, this entry can be transformed into 0 with the help of this minus 1 by simply using the operation R4 minus R3. So this form become. So in order to make this entry 1, we have simply multiplied all the entries of third row by minus 1. So this form become. Now all the diagonal entries are now become 0, and all the entries below the diagonal entries are all 0. So our objective is to reduce this matrix A into identity matrix. So the same operations, the same sequence of operations is now applied in reverse order, that is starting from this element to this element. So this first here our objective is to reduce these entries into 0 with the help of this one. So the corresponding operations are, this entry can be reduced into 0 with the help of this one by utilizing the operation R1 plus 2R4, and this entry R2 minus 3R4, this entry by R3 minus 3R4. So the corresponding form is this one. Now with the help of this entry, we have to convert these two entries into 0. So the corresponding operations can be taken as R1 is replaced by R1 plus R3, and R2 is replaced by R2 minus R3. So this form will be generated after utilizing these two operations. Now in next step, our objective is using this pivot entry, this diagonal entry, we have to reduce this 1 into 0. So therefore the corresponding operation can be taken as R1 first row is replaced by R1 minus R2. So therefore we have reduces the matrix A into identity matrix, and the corresponding changes in identity matrix is actually inverse of given matrix A, that is our inverse. Okay, thank you.